Alright guys, this is the 7.3 notes. 7.3 talks about graphs of reciprocal functions. This is the do now. It's attached under today's folder. I want you guys to pause the video at this point and try to do numbers 1, 2, and 3. When you are done, play the video, see if your answers match up with mine. Also, I want you to try to find domain and range for each of these problems. So make sure you are identifying domain range. Okay. Let's take a look here. So number one's first. If you're looking at this graph, first looking at the table before we get to the graph, just double check your numbers, make sure that they match up with mine, okay? And you notice that at 0, it's undefined, right? That should make sense to us because of this denominator here. We know that we can't plug in 0, so our function's not defined. And at that point, that means that we can't plug any zeros. We're not going to get any values at x equals 0, which creates a horizontal asymptote. Vertical asymptote. Now, from this table, you should also notice that you're not going to get any y equals 0 points, okay? Which creates a horizontal asymptote. Look at your function. Think, is there any number I could plug in for x that's going to get me y equals 0? No. All right, so we get two asymptotes, a vertical and a horizontal, and we get two branches of our function, okay? One down here, one in the top right corner, and here is our domain and range then. For number 2, okay, similar, except we have this minus 2. All right, and think about it's attached to the x. Think about other functions like quadratics, the square roots, cube roots. When we subtract 2 from x, we should know by now that that is something, it's going to be a translation. It's going to move our functions 2 to the right. So we have the same exact function as number 1, except we're moved 2 to the right. We're undefined at the point x equals 2, and there's our domain and range. For number 3, okay, same as number 2, except instead of 1, we have a negative 3. So think about what a negative value, negative coefficient does to all our functions. They reflect them, okay? So instead of going one branch up here and another down here, it's flipped. I have one top left, I have one bottom right. I still have my vertical asymptote at x equals 2 because I can't plug 2 in my denominator. I have a horizontal asymptote at 0, and here's my domain and range. Make sure when you're writing these asymptotes you put x equals or y equals. Okay, these are called reciprocal functions. Today we're going to learn how to graph them, and they create these things called hyperbolas, which have 2 branches, all right, and they have 2 asymptotes. So we're going to figure out how to find out where the asymptotes are, how to pick points to plug in for both of our branches. Okay, so this is 7.3 reciprocal functions. We're going to start off with notes. After these notes are done, you're going to want to have some graph paper out. Alright, so if you look back to number 1 in your do now, it was y equals 1 over x. This is the parent function, okay, of reciprocal functions. That's as basic as we can get. And it's called reciprocal functions because we have y equals 1 over our other variable x. Now, in 2 and 3, we transformed it a little. And here's the general form of how translations work with these things. Again, there's an h and k in like all of our other problems. It's a over x minus h plus k. And that h, k, and a do the same exact thing that they do in all of the other functions we've dealt with this year. Okay, if you see a function that looks like this, it creates what we call a hyperbola. Which has two branches. Okay, also has two asymptotes. There's a vertical asymptote that happens at x equals whatever our h value is. And our function never crosses vertical asymptotes. And they're also going to have horizontals. Those are at y equals k. For today, we're not going to be crossing horizontals. In 7.4 next class, you'll see the cases where horizontal asymptotes can actually be crossed. Alright, so we got to identify the h and k. That'll tell us our vertical and horizontal asymptotes. This parent function is also going to be important for graphing purposes for us. Alright, here are the steps to graphing. Okay, step 1, graph the parent function. So we're going to identify what the parent function is. We're going to ignore the h and k. We're going to then move x over to the other side of our equation so that it looks like x times y equals a. Okay, and that first thing we're going to do, we're going to graph some of the points for the parent function. We're just not going to fill in that line. It's going to be dotted, just like in all the other functions that we were doing. Then we're going to move them with those h and k values later on. All right, move all points h units horizontally, k units vertically. Move asymptotes h units horizontally, k units vertically, and you have to draw them in and label them. All right, make sure you make your asymptotes dotted. Then we draw the branches, and then we always should be able to state domain and range in interval notation. All right, pause the video at this point if you want to get these copied down. I'm going to move on to the graphing portion. Okay, number 1, y equals 1 over x minus 2 plus 3. First thing we are going to do, ignore h and k. Okay, ignore these two numbers and identify what our parent function is. So your parent, and there can be an a value, that's fine, for the parent function. But for this case, it's going to just be 1 over x. And we have an h value of 2. That means we're going to go 2 right. We have a k value of 3, which means we're going to go up 3. Okay, and when I go to make my table of values now, I want to use this parent function. And the easiest way to do it is to move x over to the other side. So I have x times y equals 1. And the way I want you guys to pick values is just think of combinations of x and y that are going to give you a product of 1 when I multiply them together. Okay, I make a table of values. Alright, and I'm just going to try to get at least 6 points. I want 3 points from each branch at least. Remember, there's going to be 2 branches here. So I'm going to plug in some points, alright? Let's say if I plug in x is 1. First off, notice I can't plug in 0 for either of these, right? So I'm going to just start off at 1. If I plug in x as 1, I can plug in y as 1, and 1 times 1 gives me 1. I can do negative 1 times negative 1. That also gives me 1. Alright, and the way I will typically go through this is I'll find a set of numbers that works. I'll flip them, I'll flip the signs, and it gives me some points from that. Okay? Now, that's it for ones. Okay, I can't do any other combination there. How about 2? If I do 2 for x, I would need 1/2 for y. I can also do negative 2 times negative 1/2. So there I just flip the signs. Now I can flip the numbers. Instead of 2 times 1/2, I can do 1/2 times 2. And then I can flip the signs. A little different than anything we've done, but really you're just starting out from the origin, work your way out, pick points that are easy to plug in and to graph. Okay. Remember, those points though aren't going to be our final answer. We're going to have to shift them. Okay. So let's plot these points. So I have 1, 1. I have negative 1, negative 1. 2, 1/2. Negative 2, negative 1/2. 1/2, 2. Negative 1/2, negative 2. Alright, and I'm not even going to make you guys put in the dotted lines for this one because you're going to see it's going to get a little confusing to tell which dots go with what. Alright, so just plot these points. Now the next thing that I do is I like to put my asymptotes in, just so I have an understanding of where the two branches are going to fall. Alright, to do that, look at your h and k. H tells me that there's going to be a vertical asymptote at x equals 2. K tells me that there's going to be a horizontal asymptote at y equals 3. Make sure you label them. Okay. Now what I do now should be helpful. Think back to those graphs. If I have one branch in the top right, I should have one in the bottom left. If I have one top left, I should have one bottom right. They're always opposite. Okay. Take your points now, and I'm going to do one branch at a time. Okay. I'm going to take this point here. I'm going to shift it 2 to the right, 3 up. 2 to the right, 3 up. 2 to the right, 3 up. Okay, and I have to go along these asymptotes. Alright, take these 3 points now. Shift them. 2 to the right, 3 up. 2 to the right. And you should never be crossing an asymptote in these ones. Make sure your function goes all the way out along the asymptotes. Don't stop it right at the points. And that's what your final branches should look like. Domain. It's going to be negative infinity to 2. Union 2 to infinity. Range. Negative infinity to 3. Union 3 to infinity. Okay, that's it. The weirdest thing about these ones are trying to just get used to plugging in the points. I'll help you set up the table with the next one, and then I'm going to want you guys to pause the video and try to finish the stuff on your own. Okay. Alright, let's get the table set up for this next one, then you guys will finish it off. So 2, y equals negative 4 over x. This one's going to be pretty easy because there is no h and k value. So this is your parent function. Rewrite it as x times y equals negative 4. I want to think of combinations of numbers that give me a product of negative 4. Now, I don't always start off at 1, but sometimes 1 doesn't even work that well. But I'm going to start with 1 in this one. So if I have 1 for x, 1 times negative 4 will give me negative 4. Okay, I can also do negative 1 times positive 4. So there I just flipped the signs. Now I can also flip the numbers. I can do positive 4, negative 1. I can do negative 4, positive 1. All right, let's go to 2. I can do 2 times negative 2. And you want to think of numbers, guys, that give you, that are nice, easy numbers. I don't want to plug in 9 right now for x, or 3, because of this 4. All right, think about easy numbers that are going to get you to 4. 2 times negative 2, negative 2 times positive 2, and that's enough for us. All right, what else could work? You could plug in 8. 8 times negative a half. That's an easy one to do. Negative 8 and positive a half. Okay, at this point, I want you guys to pause the video. I want you to get this sketched, draw in your asymptotes, find domain and range, and then I also want you to try to do number 3, which is y equals 6 over x plus 2 minus 1. Once you're done, play the video and you will be able to check your answers with mine. Okay, make sure you're finding domain and range for both as well. Okay, number 2. So here's that table that we made, just in a little bit of a different order. I don't really care about the order that you guys do it in, as long as the points all make sense. There's no shifting that has to go on here. We have an h value of 0. We have a k value of 0. So we have vertical asymptote at 0, horizontal at 0 as well. And those points are just our final answer because there's no shifting. Again, you should always have 2 branches and they should be opposite each other. Domain and range, right here. You just got to take out those asymptotes. Last one, number 3. This one we have an h and k, so it's going to be translated. Ignore h and k. Here's my parent function, y equals 6 over x. Use x times y to create your table. And we want to think of combinations of x and y. That will give me 6. 2 times 3, negative 2 times negative 3. 3 times 2, negative 3 times negative 2. And that takes care of that combination of points. I can do 1 times 6, and all the combinations that come from 1 times 6 as well. Plot your points, shift them, h and k. Just be careful with h. Remember with your x values, x plus 2. H is really negative 2 though. Okay, add in your asymptotes, draw your branches, and then do domain and range.